Let's set the scene. You are sitting in the exam hall, the clock is ticking down, the pressure is on, and you flip the page to a classic Cambridge Computer Science past paper question. Maybe it's a Legacy 9713 paper, or maybe it's your current syllabus. Your heart sinks a little, or maybe it races because it's a massive, multi-part question all about interpreters. Now, in my experience, there are two types of students in this exact moment. Let's call them Alex and Sam. Alex is the walking encyclopedia. Alex overloads the page with raw computer science facts, right? Just dumping everything they know about interpreters onto the paper, but completely missing the analysis the examiner is begging for. And then you have Sam. Sam rushes. Sam sees the word interpreter, panics about the time, completely ignores the command word requirements, and writes a vague, half-finished answer. If we look at the examiner reports, papers are losing huge marks precisely because students like Alex and Sam are missing the ultimate system. Well, in this explainer, we're going to change all of that. We're going to navigate your exam by the stars, and those stars are your key command words. We're going to chart a highly specific, foolproof course to top marks. Now, what is genuinely surprising, almost shocking, about this number on screen is that the interpreter for high-level language translation and execution topic accounts for a massive 15% of your total paper 2 marks. I want you to really think about that for a second. 15%. That is the literal difference between a C and an A. It's the difference between missing your university offer and securing it. Whether you are building your foundation in the earlier syllabus codes like 0417, 0478, 0983, 0984, or 2210, or you are aiming for the absolute top tier in the 9618 ASNA level exams, understanding exactly how a high-level language is translated and executed is absolutely non-negotiable. It's the heavy-hitting topic that examiners intentionally use to separate the good candidates from the truly great ones. It's their ultimate filtering mechanism. So, to make sure you secure every single one of those marks, we've organized our strategy into 5 clear steps. The 15% secret, mastering theoretical foundations, the systematic processing framework, top 3 examiner warnings, and maximizing your method marks. Okay, starting with section 1, the 15% secret. Let's uncover what the exam is actually testing here, because I promise you, it goes far beyond simple rote memorization. Notice how the assessment targets 3 totally distinct cognitive domains. You need knowledge, yes, but you also critically need application and analysis. This is where we need to talk about the Peel framework: point, evidence, explanation, link. Remember Alex, who just dumps facts? Alex only hits knowledge. But when you see a command word like analyze or evaluate regarding an interpreter's execution of code, you cannot just list facts. You need to make a specific point, provide evidence from the code snippet you've been given, give a technical explanation of the methodology, like how the interpreter translates line by line, and link it directly back to the context of the question. The answers that actually score top marks integrate all 3 of these domains using that exact Peel structure. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep moving. This quote, directly from the principal examiner reports, is a game changer. It brilliantly illustrates that top-performing students secure their points by demonstrating a connected, conceptual understanding that transfers seamlessly to unfamiliar contexts. But what does a cross-topic connection actually look like on paper? Well, it means when you are discussing an interpreter, you aren't just talking about interpretation in a vacuum. You are also referencing how it handles complex binary representations under the hood. You're talking about how it allocates memory, or how data structures are dynamically updated during the translation process. The examiners are desperately looking to see that you understand the entire ecosystem of the computer, not just isolated flashcard-style concepts. Let's jump into section 2, mastering theoretical foundations. We need to build the architectural blueprint and look at the core principles the examiners absolutely demand. The entire foundation of this topic rests on your ability to integrate precise definitions and establish crystal-clear cause and effect relationships. Let's look at Sam again. Sam, rushing through the paper, writes a weak answer that just says, "An interpreter is slow." 0 marks for analysis there. But a top-tier candidate, they prove exactly why. They establish the causal relationship by saying something like, because the interpreter translates and executes the high-level language statement by statement, any loops in the code will cause those specific statements to be translated multiple times, resulting in significantly slower execution times compared to a compiled program. Boom. Do you see the difference? You are proving to the examiner exactly why something happens on a technical level. When you're applying these concepts practically in the exam, you have to use algorithmic thinking that follows this exact 4-step sequence. First, Step-by-step decomposition. This means breaking the complex translation process down into distinct phases. You have lexical analysis to group characters into tokens. Then you're checking the grammar in the syntax phase, then verifying the logic in the semantic phase. Second, you evaluate appropriate data structure selection, like how the interpreter's symbol table keeps track of variable names and their memory addresses. Next is efficient code implementation, and finally, rigorous testing. If you can walk the examiner through this exact pipeline, you are golden. Moving on to Section 3, the systematic processing framework. The absolute crucial point here is knowing how to translate all that great theory into an actual, high-scoring exam answer. Every single time you tackle a question, you should systematically follow these 5 steps. I want to do a quick mental interactive workshop with you right now. Imagine I put a complex data table right in front of you. It shows the execution times of a program run through an interpreter versus a compiler, over 100 iterations. You have a 60-second mental timer. What's the core trend? Well, first, you deconstruct the question and extract the relevant data, which is that scaling execution time. Then, you find the flaw in the logic. If a sample answer says the interpreter is faster because it doesn't create an executable file, you need to immediately identify that while the initial startup might be faster, the overall execution over 100 iterations is way slower due to the repeated translation of every single line. You have to spot these trends instantly. You really should memorize this simple deconstruct, solve, evaluate mantra. It ensures you identify the given information, break it down logically, and check for reasonableness using your PEL framework. For example, if you're evaluating an interpreter under intense time pressure in the exam hall, you deconstruct the scenario, solve it by making your point and providing evidence, and then evaluate it by giving the technical explanation, like the lack of an executable object file, and linking it back to the specific system requirements. It keeps your logic flowing flawlessly across the page. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, Section 4, Top 3 Examiner Warnings. Let's look closely at the hidden traps because the examiners have explicitly warned us about where students are throwing away their marks. According to the principal examiner reports, these are the top 3 mistakes you absolutely positively must avoid. First, confusing cause and effect. Don't just state a symptom, state the technical cause based on exactly how the interpreter translates. Second, forgetting boundary conditions and edge cases. Think about this. What happens when the interpreter hits an unexpected illegal character mid-execution? You must mention error diagnostics. Third, and this is where Sam always loses marks, your answers fail to be specific to the context. If the question is about an automated factory control system using an interpreter, your answer better mention the factory sensors and physical actuators, not just generic code. Context is literally everything. To avoid those edge case traps we just talked about, your evaluation must explicitly identify 3 things. 1. Time complexity. That's the line-by-line translation overhead I keep mentioning. 2. Space complexity. Interpreters generally use less memory because they don't generate a massive, standalone executable object code file. M3, edge cases. How does the interpreter handle syntax errors? Well, it stops immediately and reports the error, right? Which is absolutely brilliant for debugging, but totally terrible for final deployment to an end user. You have to analyze these trade-offs. Top-scoring candidates take it a step further by demonstrating evaluative thinking through these 4 actionable steps. They don't just lazily say interpreters are good or bad. They consider multiple solutions by directly comparing them to compilers. They analyze those trade-offs we just discussed, like trading pure execution speed for debugging ease. They acknowledge limitations, such as the massive security limitation that the source code literally must be present at runtime for an interpreter to work. Anyone can see your code. And finally, they justify their decisions with hard evidence from the given scenario. If you have 30 seconds to write a appeal paragraph, this is the checklist you follow. Finally, we have arrived at Section 5, maximizing your method marks. Let's cover the absolute ultimate safety net for your Cambridge exam. As this definition clearly shows, you can literally save your grade by writing down your working, because Cambridge examiners actively want to reward you for a correct, systematic process.
If you rush to the end like Sam does, and you make one tiny logic error in the very first step, your final answer is going to be completely wrong. Without any workings shown, that is a hard 0 marks. But if you take the breath to write out your step-by-step logic of exactly how the interpreter is processing the data, the examiner can see your systematic process. They can see your algorithmic thinking, and they will shower you with method marks even if your final conclusion is slightly off.
But to actually get those method marks, your working must be clearly notated, and it must utilize the precise vocabulary straight from the syllabus. You have to avoid vague, everyday descriptions. Use exact professional terms like lexical analysis, syntax error, dynamic typing, and source code translation. Execute your answers with clear notation. This all feeds into the 3 rules that guarantee top marks: command word decoding, Peel, framework application, and your time management matrix. Simply writing out the logical sequence of translation phases clearly on the page ensures the examiner knows exactly what you understand about the technology.
Take a moment to really think about this question. The entire blueprint is fully laid out for you now. We've covered the 15% secret, the absolute necessity of cause and effect relationships, the dangerous traps of context, and the incredible lifeline of method marks. The next time you look at a piece of translated code, will you be able to systematically deconstruct it? Your understanding of this entire ecosystem depends on it. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.